Hello, in this video I want to look at finding a confidence interval using a calculator. So notice that on the left hand side we have the heart rates of 25 individuals, which in this case they were students. So here we look at these 25 and let's suppose that we want to find a 90% confidence interval for this data. So we have to input all of the data into our calculator manually. And in my case, I had to go to stat edit, and I had to individually input every one of the the beats per minute for the heart rates of the 25 students. And I actually did make a error somewhere where I missed one of the heartbeats. I think it was like the 65. And in any case, like if I was to just sort the data just by telling it to sort, hang on, sort my list, then I can check the data just to be sure that everything is okay. So 61, 63, yeah. So it looks fine. Okay, so once the data has been introduced, well, we could do several things at this point, like if we wanted to conduct a 90% confidence. But let's say that you needed to find the statistics. Well, you already know that you can find the statistics by using one variable stats. And then from there, we have that we can calculate the one variable statistics, of which one of the main things that I got from this is that we get the sample mean. So the sample mean from here is 77.4. But notice that here we do look for the sample standard deviation, which in this case we'll use that the sample standard deviation is 9.764. But note that that the sample size is 25. What this means is that essentially we have that you would have the standard error in either case. So by taking this number divided by 5. Okay, but we're wanting a 90% confidence, which in this case the t-value is going to be the alpha region. So that would be 1 minus 0.9 equals to 0.1. So we have 0.1. But we divide that by 2, given that it's two-tailed, so that's going to be 0.05, comma, well, that's going to be 24 degrees of freedom. So from here, we could probably just say, well, take the inverse norm, t, and in this case, because it's a 90% confidence interval, then we'll use that you're accounting for not only the 90%, but the 5% that lies to the left. And here the degrees of freedom would be 24, of which in this case, if we go ahead and we look for t, okay, so t is 1.71. So we have 1.71. So this means that basically we have 77.4 plus or minus 1.71 multiplied by 9.769. Oh, actually that was a 4, I'm sorry. But all of this is divided by the square root of 25. Now, of course, if we take 1.71, we multiply that by 9.764, and we're going to divide that by the square root of 25. Okay, so here we're finding that the margin of error is 3.3, yeah, we can say 3.34. Okay, so here we have 77.4 plus or minus. If we want to use 3.3, we can, whichever, is the case, but we'll just say 3.34. So here, that means that you take 77.4, you subtract the margin of error, of which that gives us 74.06. Comma, which of course we'll take the sample mean that we found, and we'll just add that to the margin of error. Okay, so here we'll get 80.74. So what this means is that we are 90% confident that the average heart rate beats per minute is somewhere between 74.06, and 80.74. And in this case, we have that, we can basically say that this gives us a good estimate for estimating a population mean or point estimate for the average heart rate. And, the sample size was small because the sample size was 25. So here, if we go ahead and we look at, what if after we input the data, we don't really look for these calculations, like the sample mean, the standard deviation, and then looking for the t-value, because actually the calculator does, in fact, do that part as well, where you would go to stat, you would go to tests, and you would go to the t-interval. Now, in this case, we're inputting the data instead of the statistics, because we don't need to input the data, the statistics, because, hypothetically, what if we just had this data and then we just input it into our calculator, or even Excel or some software program, and, the key is efficiency. So here we just click enter, and see like how 74.06, and we see that it's 80.74. But see like how here it gave us the standard deviation of 9.76, which is more or less the same thing. And then, of course, it gave us the sample size, which, we already knew that because we had this size. So we see that this is a lot quicker, but of course, in my case, I had to verify the list that it was correct, which initially it wasn't when I input it prior to recording. And then I noticed that the sample mean was off, so then I just double checked, and then I saw that I missed a 65, so I just input it. But either way, that just tells you that you just have to correct the input entries, and just be sure that that you did input these these sample data correctly, and it was already sorted, which in that case was good on this part, because if it wasn't sorted, then I may have actually missed it. But anything like Excel could actually sort this data too, if that was an option. But either way, we see that ideally you're going to be using small sample sizes, which would be less than 30 by definition. And then we automatically would just have to use the fact that the parameters mu and sigma are unknown for this one, which means that, of course, you would need a sample in the first place.